The first question asks us to sketch this modulus graph. So as a start, what I did, I went and draw this y equal to x minus 2a, where I know the y-intercept is going to be negative 2a. So my first stage is this one, and I labeled my minus 2a, which is here. Then what is the idea behind modulus? Of course, you cannot have y being negative. For any input of your x, the output is going to be positive. So what I did, I took this particular part over here and then I reflected about the x-axis. That's how we get the V shape. And you have to indicate that this gap and this gap is going to be the same. Next, I need to solve the inequality. Because the first part asked me to sketch, so what I did as a start, I went and sketched y equal to 2x minus 3a. My gradient is 2 and my y-intercept is minus 3a. You can see it from my sketch over here. Now, as it is shown here, there is only one intersection point. Those who are doing by the quadratic, you need to get yourself out of the trap. So the best approach for this question is definitely sketching. So what I did, this part of mine is x minus 2a. The other part, which is this one, is a reflection about the x-axis. So what will you do? You will take this one and you will negate it and you will get negative x plus 2a, which is here. So when you are solving for the intersection, you will take the 2a minus x and you will equate to 2x minus 3a. You will get 5 over 3a. Now, how do you find the final solution in terms of inequality? So you need to go back to the question and you have to try to understand what is the meaning of this. So they are just telling that this line lies below your modulus sketch. So which region is that? Since your intersection is here, so it's either you are taking the right hand side or you are looking at the left hand side. So the best approach is you just put your ruler in the middle and you observe here. See, here for this particular region, the blue color is on top and then the red color is at the bottom. So that's how I know the line is lying below the modulus. So my answer is going to be x less than 5 over 3a. Next, what is the trap in this question? It's this one. The coefficient of your denominator and numerator is 6 and 2, but they have the same power. The power of your numerator and denominator is 2. Therefore, you need to create this particular constant. And how do you get this? Just take the coefficient and divide. What is that? 6, which is this one, 2, which is at the bottom here. 6 divided by 2, you will get the 3. The rest are all the basic normal procedure. You will take the denominator, of course you will factorize, and both are linear factors. Therefore, you will create a constant a and constant b on top. Rearrange, you should be able to get this solution. Now next, I need to show that the graph of y against x is a straight line. What is the meaning of a straight line? Y equal to mx plus c. Okay, in order to get this format, okay, look at what I have here. So a to the power of 2y minus 1, b to the power of x minus y. So I'm using the approach of logarithm in order to make the power to become the coefficient now. So this is the first line that you will get. After that, it's simple expansion and you rearrange accordingly and you will be able to see that this is your y, this is your m, x and the y-intercept. It is advised to outline your gradient and the y-intercept separately. Okay, next, they are giving me that a is equal to b power 3 and I need to find the p and the q. So in order to get this, I know p is my gradient. So I'm taking this particular expression and I'm going to substitute my a with b power 3. I think you can see it over here. And then I'm going to get b power 6. How do I do that? I just rearrange the ln b power 3 and this 2 will become your power over here. So 3 times by 2 you will get the 6. The rest are easy. You see, this is ln b divided by ln b power of 7. So you can just rearrange 7 times ln b. You can toggle the power as coefficient and power. So you're going to get 1 over 7. Similarly for the bottom one, rearrange accordingly and you're going to get 3 over 7 for your q. Next, they are asking us to find the gradient when the y is equals to 1. So a lot of us, what we will do, of course you will be able to differentiate it correctly, but you got to be careful because this is implicit differentiation. Okay, let's look at this. I am placing my y, and then when I do the dy dx for e to the power of 2x, I'm going to get that. For y, when you differentiate, you're going to get dy over dx. For the next one here, see this first one, for the first one and for the second one, you can pause and then you can check your solution. If I differentiate e power x, I'm going to get the same thing again. If I differentiate y squared, then I will get 2y dy dx. And when you differentiate the 6, it's just going to be a 0. But now I need to get the value of the gradient. I don't want the expression. So immediately after I'm done with this, I can take the y and I can substitute over here. I'm going to get the dy dx in this expression. But later you need to substitute your e power x. So how do you find that? Take the y equal to 1 and you substitute back into the main equation. You will get this particular complex quadratic, factorize, and you choose the appropriate x value. Based on that, you can find your e power 2x, which is the 4. When you substitute, that is going to be your answer. For question number 5, this is numerical solution. I think the first part is very easy. I made my fx by bringing the 5 plus cos 3x to the left hand side. You can switch it over as well. One of it is positive, the other one is negative. And you can conclude by saying, since there is a change in sign, the root lies between the particular interval. Now the only mistake you could make is not changing your calculator to degree. And the next one, you have to show if a sequence of values in this interval given by this iterative formula, it will converge to the root in part A. So what do you usually do? You will remove the n plus 1 and n here. You will take the 2 and multiply with the x. The rest is just a basic rearrangement. And you have to show it is exactly like 5A's question. Next, use the iterative formula and determine the root correct to 3 decimal place. Which one is your iterative form? It is actually given in part B already. So you take this one and you substitute any possible x value from this particular range. You can even do 0.72, 75, 0.79, any x value which lies in this interval. I have selected 0.75 and that's my final answer. For question number 6, you need to find the maximum point. So that is definitely a dy dx equal to 0. So this is just a normal product rule, your u and v. Okay, where would you go confused with this a, because it is not a constant. So be careful in that. Just assume it is just a constant and you differentiate accordingly. When you differentiate the x, you will get the 1. Factorize if you want to. And what happens after this stage? It's 1 minus ax divided by e ax equal to 0. You know your exponential is always positive. So 0 times by a positive value, it's just 0. So you're going to get your x value and you substitute into your equation over here in order to get your y value. Okay, next I need to integrate that same curve but limited by 0 to 2 over a. So here I'm doing integration by parts. So which one am I differentiating? I'm differentiating the x and I'm integrating the exponential. So you can look at this one. After that, you use the formula as per your MF19. Okay. And always remember a is a constant. You see, I can always take out the a and I can park it outside before I begin my integration. If you want to be slow and steady. And then show the substitution of 2 over a. You can see it here, how I substitute. And rearrange. And they want the exact value. Okay, question number 7a. It is a very easy trigonometric proving. All you need to do is difference of 2 squared. What is a squared minus b squared? Of course, you know a minus b and a plus b. So what are they actually testing you now? It's a power 4 minus b power 4. It's a very basic IGCSE concept. A squared plus b squared. Okay, what is nice now? Because you're getting cos squared plus sine squared, which is exactly equal to 1. Then you can look at your trigonometry formulas in your MF19 and you'll be directly getting cos 2a. Then the next part, they use the word hence. So you need to use the part A and they want the exact value. So how would you do this? Look at this part. Cos power 4 theta minus sine power 4 theta. This is exactly cos 2a from part A. So you just substitute and it is all ready for integration. This is easy. Now the next one, it has a power for both the sine and the cos. And you know you can't directly integrate. In that case, go to MF19 and you get this particular trig formula. Then what are you going to do? In your question, the variable is theta. But in your formula sheet, the variable is x. So you have to change it later on. You can see here I'm also making a mistake. Let me change it. It is supposed to be a theta. Okay, let's go back. So sine 2x is equal to 2 sine x cos x, which is this one. Now what I'm going to do, I'm going to square both sides. I'm going to take all of this and I'm going to square it. And I'm going to do the same thing over here. So 2 squared, you're going to get the 4. And then sine squared x cos squared x. This one, I'm maintaining it like this. And then I can pair this part with this one. Can you see that? And it's just sine, I'm changing my variable, sine 2 theta power 2. Okay, next. Is it ready for integration? No, because it still has a power. So you need to try to remove the power. And how? Again, use your MF19 and you can use cos 2x here, which is equal to 1 minus 2 sine squared x. In your question, you are having 2 theta. But in your formula, it's only a x. Can you see that? It's a x on the right hand side. So what you need to do, you need to manipulate the angle. Watch out, when you are manipulating the angle, it only affects your angle. It doesn't affect your coefficient. So the x here is going to become a 2x and this 2x will become a 4x. Then you rearrange accordingly until you get 1 minus cos 4x over 2. And what am I doing with the 2 at my denominator here? I pull it out to make my integration easy. I just wrote it as 1 over 2. And after this, I'm very sure you can do this. When you integrate cos 2 theta, just use formula sheet. Sine 2 theta over 2. Take this 2 theta, differentiate and you put it on at the bottom. Similarly, take this 4 theta, differentiate and you put it at the bottom as 4. You integrate your theta, your 1, you're going to get a theta. And you substitute your pi over 8. Do very carefully step by step to avoid any careless mistake. Question number 8, I need to find the vector equation of L. This is quite easy because they already told it passes through B and C. And my answer and your answer could be different. I am selecting point B over here. If you want, you can even write point C. My direction vector is BC. Yours can be CB as well. You can even simplify this and make it into a 1, 1, negative 1. So there are multiple answers for this one. So don't be afraid if you did not get similar solution like mine. Now the next one, they are asking us to find the point of intersection of L1 and L2. Okay. So how do you do this? So you have vector equation of L1 and then you have vector equation of L2. There is an intersection and you need to find it. What is common for both? They are x, y and z. And you know your x value is row by row like this. Your x is 5 plus 3 lambda. And what is your y? What is your z? Okay, do the same thing with your L2. You can see that I took from here and I wrote down my x and the y and the z. And I compare it with my L1 as well. And I try to solve the x and y simultaneously. which will give me mu as 3 and lambda as 2 over 3. Do not be afraid. You can be solving your x and the z simultaneously. You can even do y and the z simultaneously. All this will never affect your final answer. Of course, your mu and lambda will be different. Once you are done with your mu and lambda, since they are asking you to find the point of intersection, you can use either one of it and substitute back into your line, either 1 or 2. So if you want to use line 1, then you substitute your lambda value, which is 2 over 3. If you want to use line 2 to get your final answer, then you substitute your mu as 3. Both must give you the same values. Okay, in part C, they are saying the point D is such that AB is equal to BD. Of course, they are referring to the distance, and I need to find the position vector of the D. What is position vector? I need to find the OD. Okay, as a start, what am I doing? Since they said the D lies on L2, what can you... You see here, your A here, it's exactly here. So the line to L2 has the point A in it. So I hope you have realized that while you were doing it. So I know D is a point on the L2. So what am I doing? I'm getting the X and the Y and the Z from the L2. Can you see? The same X and the Y and the Z. If I can find out what is my mu value here, then I'm technically done with the solution. So your challenge is, how will you find the mu? So in order to find that, first you find the length of AB. So you can find the vector AB, then you find the magnitude of that. So do the same thing now for BD. So you know the point B, and we just got our D here. So you just go and subtract. Can you see? These are all my D and this is my B. I minus and I got my direction vector BD. So using this, I can actually find my distance as well. Do similar method like this. Take all of this, square it. Take all of this, square it. Take all of this, square it, and you sum them up. And that is what I'm doing row by row here, and then I add it. So when I add up, I'm getting 14 mu squared, which is here. When I add this, I'm getting minus 60 mu, which is here. If I add this, I'll get 66. So the 66 get balanced. It's a 0. And your mu is going to be 30 over 7. Take the mu and you substitute into your D over here. And that is going to be your position vector. For question number 9. Yeah, they asked you to express ZW. So Z is given, W is given. This is easy. You can just expand. Just be careful. Your I squared is negative 1. So you just solve and you're going to get your A and B accordingly. The next part is asking you to leave the answer in the Euler form. So what is the meaning of this R? R is exactly the magnitude. Theta is exactly your argument. So how will you find your magnitude? Just take the X and Y, square it and square root it. So I think I did not show for this one. So what you will do, your real part is 1, take that and you square. Your imaginary part is minus 1, take that and square. You will get the R value as 2. How will you find the argument? So the best approach for this is to always sketch. So the X is 1 and the Y is minus 1. So you know it's here. So from the x-axis, you are going clockwise. So your answer is definitely going to be negative in order to indicate the direction. But the angle, it's definitely 45. How do I know? Because I have 1 and negative 1. Or you can use the formula tangent inverse imaginary over real, which I have done it here. Okay, do the same thing for your W. So what is W? W is negative 3 plus 3 is 3. So the distance is going to be 6, the length. The argument, okay, let's sketch where is this, in which quadrant is this lying. X is minus 3 and the y is on the positive side, so somewhere here. My drawings shows as though they are having the same gap. Of course it is not, yeah. One is -3, the other one is I think 5 point something, so it needs to be a little higher. Okay, let me just correct it. So it's somewhere up like this. So you need to figure out what is this angle now. So how would you find it? In order to find it, I can find how much is this one first. Then I can do 180 minus the answer. So I have done the same thing. 180 minus tangent inverse imaginary over real. Take your imaginary here. Take your real part, which is here. I'm avoiding the negative because I know the concept. I am finding the angle here first. This one first. Then I do 180 minus the answer. Okay. The next part of the question wants me to prove the OAB is an isosceles right angle triangle. So let's see, they are indicating our W as A and the ZW as our B. So I have outlined it here, and then I'm going to use this in order to prove. Let me park it here so that you can visualize. So how do I start solving this? First I went to this particular length OA, because I can get this from part B. I know it's already 6. I just only found the answer, and then I know the A and B coordinates, and I'm using that in order to find the length. By doing this, I can show that OA is equal to AB. So where is AB? AB is here. So I just managed to show that this one is equal to my OA. Next, I need to show that it is right angle triangle. Okay. How do I show it's right angle triangle? I'm using the approach of gradient. I'm finding the gradient of OA, which is -3. You can just do rise over run. Okay. Then for gradient of AB, I'm getting 1/3. Then I'm just doing the multiple of the gradient is going to give me -1. Therefore, since the sides are the same, OA is equal to AB, and the multiple of the gradient is -1, I can show that it is isosceles right angle triangle. Part D, you need to prove this given statement over here. Okay. How do I even begin if you really don't know? You see, set 3 plus 1, set 3 minus 1. When you are solving either part A or part B, somehow or other you are already seeing the coordinates again and again. So you know it is part of the ZW. Okay, you can go up to visualize. See this one. You must have this instinct. You are taking the Y and you are trying to divide with the X here. Okay, the imaginary divided by the real. And they are giving you 5/12 pi. 5/12 pi. So you can directly apply this particular rule. Argument ZW is equal to argument Z plus by argument W. Get this from your part B, also from your part B. Only this one you need to apply the formula. Tangent inverse imaginary over real. You directly take from the ZW. When you simplify, you can see you have 3 everywhere. You just divide everything by 3. And you will end up with this. You add these two, you will get 5/12 pi. The tangent you can move over here and then shown. Question number 10. It is a guided question, and after this you can use quotient rule if you want to be slow and steady. U over V. Okay, you can see the process. This is my V, how I have put the power outside to be quite careful. Power down, new power, differentiate the inner part. When you differentiate the 1, you're going to get a 0. Even many students will be doing cos theta power of -3 and you will differentiate directly. That is also possible. Okay, just slowly show. Just be very careful with your quotient rule. Remember the bottom one is V squared. So V du minus U dV over V squared. So cos theta to the power of 3 being squared. So you will get a power of 6. You simplify, done. Okay, now part B, they are saying, you know, this is definitely a differential equation, and it is a 8-mark question. So I am very sure most of you have rearranged the variables correctly, the theta with the theta, the x with the x. Now, how do you solve this one? It is actually from your part A. Okay, what is happening in part A? They are telling when you differentiate secant cube theta, your answer is going to be this, and you manage to prove it. So the reverse process is definitely integration. That's it. And your question is just this: what is the integration of sine theta multiplied with secant to the power of theta? So you just take this constant and you balance it. You divide here by 3 and you divide here by 3. Done. So this is going to be your solution. Okay. So you put it over there. Now the second part, how do you do this? This is also quite easy. Okay, a lot of students might have taken this, and you know when you differentiate this, you are getting a 2x. But now the problem is you have a plus 3. So that should give you an idea of breaking the fraction into 2 parts. So the first one and the second one, where my denominator is same. So my numerator, one of it is x, the other one is a 3. So this becomes your ln form. And when you differentiate this, you are getting a 2x. If you can't remember, you take your formula sheet. This is f prime x, this is fx. And when you integrate, your answer is going to be ln modulus fx plus c. But now, if I make this to be the one that I want, then I have to balance it by the half. Okay. So this is quite easy for many. Okay, the second one is also easy because it is from MF19. Take the 3 and you can keep it outside because it is just a multiple. And this format, it's also in the formula sheet under integration. Done. And you can put your plus c. Why am I not putting a modulus here? Because x squared plus 9 is already positive. So a normal bracket will do. Okay, next step. The theta value is pi over 3 and my x value is 3 now. Theta is pi over 3. Okay, quite simple. You substitute accordingly. Tangent inverse 1 over 1, it's equal to pi over 4. Cos pi over 3 is half, and you don't forget to cube it. Okay, and you're going to get a c in this manner. Now question is asking me to find what is the cos theta when the x value is 0. You just rearrange everything accordingly. So these are my c now. And I'm going to place my x value as 0. So this is a 0, this is a 0. That's it. Okay, rearrange accordingly. You know this whole thing is going to give you a 0. And this is half ln 9. I am trying to simplify. See, I am trying to simplify here. You don't have to. You can just directly input it into the calculator. You go step by step. And that is going to be your cos theta. Remember, cos theta needs to range from 1 to -1. There is no way your answer is going to be anything outside this boundary. That's a way for you to check when you are going wrong or making any careless mistake.